Okay, welcome to the last lesson in Unit 2 of Quadratics, solving quadratic linear systems. If you could think back to grade 10, when you were asked to solve linear systems, that was when you had two lines that were on any given xy grid, and you had to figure out what their points of intersection were. So there's a couple possibilities. You could have two lines intersecting that would meet at one spot. So for example, I could have a line like right here and another line right here. And then this point, or this point of intersection, we would call this the solution. And so that would be the point of intersection. And we were able to solve this in a couple ways. We could use substitution if we were given the two equations, or we could also use elimination, or we could do it by graphing. So I guess there's three ways. Now, for this unit, we're going to learn or figure out how can we use the same processes we did with solving linear systems by solving a linear and quadratic system, which means on any given xy plane, what if we had a parabola and there also happened to be a line on the same system? How many times can those things intersect? So I want you to think about that for a second. If you have a system that contains both a quadratic and a linear function, how many different ways or how many points of intersection could exist? Well, let's draw it out here. So one way that these could both exist is if I drew a line straight through the parabola just like this. Let me just change the color here. Make it green. So this parabola right here would have two different points of intersection. It would have one point right here and one point right here. We call this, where it has 2 points of intersection, we say that this line is secant to the parabola, which means it touches in 2 points. It's also possible for us to have a line that just grazes the parabola. So let's say we had a line that came through just like this and just grazed the parabola right there. This would in fact only have one point of intersection. So let's change the color here. Let's make this one orange. And so I can make the point of intersection right there. So even though it looks like it touches it at more than one spot, this would only touch at one spot. We say that this type of line is tangent to the parabola, which means that it touches, but it only touches once. And of course, it's also possible for a line to not even touch the parabola at all. What if you had a line that, started over here and then just went in this direction and totally missed the parabola? So this line here would have no points of intersection. It doesn't have a special name like the tangent line or the secant line. But this one would have no points of intersection. So there's 3 different ways that that can happen. Just like how a parabola has 3 different numbers of solutions that it could have if it touches the x-axis. I mean, that makes sense because the x-axis is also a line, right? So you could have 2 solutions. You could have one solution where the vertex is right on the x-axis, or you could have no solutions if the vertex is below the x-axis and it's pointing downwards, or if the parabola's vertex is above the x-axis and it's pointing upwards. So now let's see if we can use algebra to help us out to decide if we're given a quadratic equation and a linear equation, can we figure out if they have 2 points of intersection, so the line is secant to the parabola, or if there's only one point of intersection, so the line is tangent to the parabola, or maybe there's no solutions at all. Let's look at an example. Given a quadratic function of y equals negative 0.48x squared plus 4.8x, and a linear function of y equals 0.24x plus 7.2, find the point or points where the two functions intersect. So here I've written step 1, and the same as if we had two linear equations and we were trying to solve a system of linear equations, what we'd want to try to do is maybe use substitution and set the two equations equal to each other. What I mean by that is both equations start with y equals. The quadratic equation has y equals all of this stuff, and the linear function has y equals all of this stuff. So at a given point of intersection, we know that this y has to be equal to this y. So we're going to set these two equations equal to each other to figure out what their points of intersection are. So let's do that as step one. So step one, we're going to say that negative 0.48x squared plus 4.8x will have to equal 0.24x plus 7.2. Now that we've set these two things equal to each other, we know how to solve this. We're going to move everything over to one side and then make the other side equal to 0. And from there, there's really two ways we could solve. We could solve using factoring, although factoring in this situation doesn't look too pleasant. So our other option is to use the quadratic formula. So that's what our goal is going to be. So let's move everything over to one side and then use the quadratic formula to solve for what x needs to equal. So the 0.24x and the 7.2 are going to move over to the left-hand side. So the negative 4.8x squared is still here. Same thing with this 4.8x. Once the 0.24 moves over, it becomes negative. Same thing with the 7.2. And so let's just combine these two x's together here, collect the like terms. So we end up with negative 0.48x squared, 4.8 minus 0.24. Well, let's get out our trusty calculator here to help us out to make sure we can do it right. So 4.8 minus 0.24, we have 4.56, positive 4.56x. And now we're ready to use the quadratic formula. So for our quadratic formula, we're going to have a values, b values, and c values. So in this question, we have a is equal to negative 0.48, our b value, and our c value is equal to negative 7.2. Our three numbers right there, there, and there. And if you forget, our quadratic formula looks like this. X equals negative b plus or minus square root b squared minus 4ac all over. Okay, so let's throw all these numbers into our quadratic formula and solve from here. So negative b, so negative 4.56, plus or minus the square root b squared, so 4.56 all squared, minus 4 times a is negative 0.48. We're going to have to watch this when we multiply this because we have two negatives now multiplying. And then times c, which is also negative, so negative. And so we're going to get two solutions here. One solution that involves the plus sign here, and one solution that involves the negative sign. So let's work those things out. Interesting thing. So x equals 2 or x equals 7.5. Okay, so what does this tell us? Well, this tells us that when we found the solutions to the two equations where one was a quadratic and one was a linear, so basically a parabola and a line on the same graph, there's two possible answers for what x could be, which means for us that there are two solutions to this problem. The line crosses the parabola in two different spots. One spot where x equals 2, and the other spot where x equals 7.5. Or, in other words, the line is secant to the parabola. Well, we know that a point isn't just an x value. It's an x value and a y value. So now we have to figure out, well, for when the value of x is 2, what does y equal? And when the value of x is 7.5, what does y equal? And luckily for us, there's two different equations that we could use. One of them is the quadratic equation up here, and one of them is the linear equation up here. And you can use either one, because both of them will give you the same answers for y. Now, if it were me, I'd probably pick the linear one, only because in this question, the numbers seem way easier to work with than the quadratic one. But again, it doesn't matter which one you use. So let's plug both of these answers for x into the linear equation and then figure out what our y values will be. It's going to equal 0.24 times x, which is times 2. And then for this solution, when x is 7.5, we get y is equal to 0.24 times 7.5 plus 7.2. For POIs, there's more than one. Points of intersection are, and the first point is 2 and 7.68. And the second solution is when x is 7.5, y is equal to 9. So here's example 2. Determine whether a linear function intersects with a quadratic function. So here's our two functions. Y equals negative x minus 2, and y equals negative 2x squared plus x minus 3. So we have two different functions, one linear, one quadratic. We just need to figure out if they intersect. It doesn't say where they intersect, just if they intersect. And here's the greatest thing that we know based on points of based on using the quadratic formula. We know that we're going to set these two things equal to each other. So just like we did before to find points of intersection, I'm going to set equation 1 equal to equation 2. If you thought that we could just use the discriminant, you'd be correct. So let's just use the discriminant. Remember the discriminant, so our b value is -2, so this would be -2 all squared, minus 4 times our a value up here is 2, and our c value up there is 1. Well, 4 minus 8 is -4. So if our discriminant is negative, remember, that means no solutions. There, that was easy. And I didn't need to go into the quadratic formula to be able to figure that out. I was able to just use the discriminant. But your first step needs to be to set the two equations equal to each other and move everything over to the left-hand side. Then you can use the discriminant to determine how many, or if, the two things even intersect. Okay, let's look at one more example. Here's the last example we're going to look at. If a line with slope 4 has only one point of intersection with the quadratic function, and here's our quadratic function here, it's given in function notation, which we're going to talk a little bit about starting in Unit 3. But you can just assume that this is the same thing as saying y equals. So y equals 1/2 x squared plus 2x minus 8. So that's the quadratic equation. What is the y-intercept of that line? And it says model your linear equation using slope y-intercept form. Okay, so we're only given a quadratic function in this question. We aren't given a linear equation, but we are given a clue as to what the linear equation looks like. We're told that the slope is 4. And the question's asking, what is the y-intercept? Well, okay, so we can remember back to grade 9 and grade 10. Remember, we can write a linear equation in slope y-intercept form where we have y equals mx plus b. M represents the slope, and b represents the y-intercept. Okay, well, this is perfect. We're told the slope is 4. So we know that our equation is going to be y equals slope of 4, so 4x, and I don't know the y-intercept, which is what I'm looking for. So I'm just going to keep that as a plus, and I'm going to change the letter to k, only because you'll see later, if we have to use the quadratic formula, we use the letters a, b, and c in the quadratic formula, so I don't want to get us confused. So I'm just going to change the letter b to k. Doesn't matter, they both represent numbers. So just like we did before, we're going to set the two equations equal to each other because we're trying to find points of intersection. So let's do that. I'm going to set 1/2 x plus 2x minus 8 to my linear equation 4x plus k. Let's not be too afraid that there's a k in here. We can still work this out. And again, move everything over to the left-hand side. So 1/2 x squared, move the 4x over so it becomes -4x. Then we're going to have a -8, and then this k moves over and it becomes negative as well. So 1/2 x squared plus 2x minus 4x minus 8 minus k. These two terms here we can collect because they're like terms. So we're just left with 1/2 x squared, positive 2x minus 4x is -2x, and then -8 minus k. Okay, so now we've gotten basically our three terms, and it's hard to see this, but the x squared is one term, the x, or the -2x, that's the second term, and this -8 minus k, well, because k is just some random number, we know that -8 minus k, this will just end up being, again, a number by itself. So before we move on, let's just consider the fact that this is together. We're going to keep this as one term going on in our thinking, because if I'm using the quadratic formula from here on out, I know that the 1/2, that's my a value, the -2, that's my b value, and now my c value is always just the number by itself. Well, -8 minus k, that is going to be my c value. It's the number by itself. We just don't know yet what k is. We're going to have to solve for that. So let me write these out again. So a is equal to 1/2. Maybe we can change this to a decimal just to help us out. B is equal to -2, and C is equal to -8 minus k. We could use the quadratic formula to help us, but we're given one other clue here in this question. Can you see it? Yeah, it's right here. We're told that a line with slope 4 only has one point of intersection with the quadratic function. Well, one point of intersection, that tells us that this line is tangent to the quadratic. But what else does it tell us when we write it in? So we want to use the quadratic formula. Well, we know that the discriminant has to equal what? We know the discriminant needs to equal 0. Right? With only one point of intersection, the discriminant has to equal 0. Or, in other words, b squared minus 4ac has to equal 0. So we can use this to help us out. If I know that b squared minus 4ac equals 0, let's plug in our values for a, b, and c, and then try to solve for k. Because in the end, that's what we want, right? We want the y-intercept of our linear equation, or basically the k value. So let's sub them in and solve for k. So b squared minus 4ac, b is negative 2. So we're going to have negative 2 all squared minus 4 times a is half, times c is negative 8 minus k. I have to do a little bit of algebra here. We know all this equals 0. Negative 2 squared, that's 4. Negative 4 times half, well, half of 4 is 2, so this becomes negative 2 times negative 8 minus k. And so this negative 2, it's going to have to expand or distribute itself into the bracket before I can operate it with this 4. Remember, BEDMAS says I need to multiply before I can add or subtract. Don't make that mistake. So let's multiply this negative 2 into the bracket. So the 4 stays here for now. Negative 2 times negative 8 is positive 16. And then negative 2 times negative k, well, that's positive 2k. And we know that equals 0. Okay, so looking at this, we want to isolate for k, so let's move these two numbers over to the other side. 4 plus 16, that's 20, and when I move it over, it becomes negative. So 2k is going to equal negative 20. And look at this, k, when I divide out the 2, equals negative 10. So, looks like we have it. The k value in this question is negative 10, or in other words, our linear equation looks like this. Y equals mx plus b, or 4x, and then the k value is negative 10. So y equals 4x minus 10 is the linear equation. Thus, the y-intercept is negative 10. Booyah! So that concludes our lesson on linear quadratic functions, or I guess systems of linear quadratic functions. If you need to go over anything, just rewind the video and watch it again. Otherwise, good luck with your homework, and be prepared for your test coming up later this week.